Hello YouTube. In this section, let's talk about aggregate operations. To better understand the concepts in this section, review the section lambda expressions and method references. And the Oracle tutorial have totally 3 pages about this topic. And you can read more detail in the Java 8 in action. For those developers already know about Java 7, Java 8 in Action is a good book to bridge through the Java 7 to Java 8. It talks about lambda expressions, function references, and streams. Also talk about the complete feature, parallel streams. So a good book to bridge from Java 7 to Java 8. In this section, we will try to have a walkthrough between the 3 pages tutorial and a whole book. We only cover about the OCPJP needed topics in the Java 8 in action. So it's something in between. For what do you use collections? You don't simply store objects in a collection and leave them there. In most cases, you use collections to retrieve items stored in them. And consider again the scenario described in the section lambda expressions. There we have a person class. The person class model a social network person, has a name, birthday, gender, email address, and other fields like interest, city, town. And traditionally, the administrator get a collection of the members and iterate through and do some action on those members, like print their name. With Java 8 Stream API, the code is more declarative. So we first get a stream from the collection. Then, for each of the members, we send a lambda expression, tell the system how we want to deal with the element. In this case, we print the name. And although in this example, the version that uses aggregate operations is longer than the one that uses a for each loop, you will see that version that uses bulk data operation will be more concise for more complex tasks. That is saying, the way is better because we didn't tell the machine how to iterate. We just declare what we want to do with a stream of elements. In other examples, like here we have a more complex example. We can chain those actions together. We can filter on the members. We can map them to other type. And we can do average, finally get the result. So this is more like MySQL style. MySQL style, and just supply where clause, and clause, group by, and the having those keywords just declare what the developer want to do. They didn't have detail about how to implement those where clause, and clause, and a group by clause. Those are handled by the machine. Programmer just write query style programs. Here the same thing. Java 8, we get a stream. This is elements we want to deal with. And this is like a where clause. We want to filter them. And after that, this is like a MySQL function. We map our result to another type. Finally, we have aggregate functions. We do the average. We can do count. We can do sum. Those are functions defined by the MySQL. So you see, this style is more like MySQL. MySQL never specify for each while loop. There's no such things. Those are machine details. We just specify the query-like code. So here is an example. Bulk data operations examples. Okay, and I already copied into Eclipse. So let's run the program. It prints out the members in the traditional way and print out the members in the Java 8 Stream API way. And there's other functions with the traditional way and new way. So let's take a look at the program. We need to dig into the library a little bit. First, we got a collection of person. And traditionally we get a iterator and we print. In a new way, we get a stream from the collection. Notice collection API is updated in Java 8. A default method is added, and it returns a stream of element E, which is the same type of the collection's element type. And what it returned is a stream support stream. And it calls a factory method to create a stream from your collection. The iterator tell the machine how to create the stream. For OCPJP, we don't need more detail about the iterator, but this is basically how Java 8 Stream API retrofit into the collection API. As long as you are a collection, you can get a stream from it. And stream have a terminal operation for each. So let's dig into the for each. For each, take a lambda expression. The lambda expression is a consumer, and it returns nothing. So if we dig into the consumer take the collection's element as a parameter and do something with it, but returns nothing. So your stream end here. That's why it's called terminal operation. It didn't return another stream. Your stream is terminated here, and it processes the collection's element or the stream's element. So you need to pass in a lambda expression which implements the consumer functional interface. Here we do send a consumer. The consumer takes E as a parameter, didn't return anything, so this is a consumer. And by that way, we print out the name of the member in the collection through the stream. Okay. Check the output. Print all the members. Let's go back. Okay. Pipeline and streams. A pipeline is a sequence of aggregate operations. The following example prints the male members contained in the collection roster with a pipeline that consists of the aggregate operations filter and for each. We call the pipeline because it's like a water pipe. The water came out from your collection through the stream. It's like a faucet, okay? tap out the collection from the faucet, and it flow into a pipe. Finally, it go into the sink. For each is consumed, they go into the sink. This is a intermediate pipe. And in this pipe, what we do is we filter. Traditionally, what it does is we iterate through the collection, and we also filter with the if. If a gender equal male, then we let it go to the next stage, which is consume it, and we print the name. More declaratively, we can pipeline them, add a filter as an intermediate operation. So here, a pipeline contains the following components: a source. This could be a collection, an array, an aggregate function, or I/O channel. In this example, the collection roster. This is our source. This is our faucet. Okay. 0 or more intermediate operations. It's an intermediate operation. An intermediate operation, such as filter, produces a new stream. A stream is a sequence of elements. Unlike a collection, it's not a data structure that stores elements. Instead, a stream carries values from source through a pipeline. This example creates a stream from the collection roster by invoking the method stream. Okay. Your water tank stores water, but your faucet doesn't. The stream is like a faucet. It doesn't store your data. It's just an outlet from your data source to the pipes and terminals. The filter operation returns a new stream that contains elements that match its predicate. The operations parameter. So filter take a lambda expression, which is a predicate, and returns another stream so that you can send it to the next pipe or terminal. It returns a Boolean value true if the gender field of object E has a value person, sex male. Consequently, the filter operation in this example returns a stream that contains all the male members in the collection roster. Finally, a terminal operation. A terminal operation such as for each produces a non-stream result. So as we saw last time, it's a return void. You didn't get a stream anymore. A collection, or the case for each, no value at all. In this example, the parameter of for each operation is a lambda expression. This is a consumer, which invokes the method getName on the object E. Okay, enough of talking. Let's go to check the example. Here, this is an example. We only want the male member, and we want to print their name. So this is a source. Source is a collection. It stores our data, and through the stream, which is our faucet, we get the sequence of elements. Then we pass into the intermediate operation. The intermediate operation filter, if we take a look at the definition, it's take a predicate. So you need to pass in a lambda, implement the predicate. And it operates on a stream and return a stream of the element's type. Okay. So it's take your element and return a stream of the element. And a predicate, we already learned from the lambda expression. Predicate is a functional interface. It takes your element and return a Boolean, true or false. So here we passed in the lambda expression. which is a predicate. It take your element and return a true or false. So this is a predicate. And the filter operate on a stream and return another stream. Okay, so this is called intermediate operation because it take a stream, return a stream, like a pipe. And finally, the terminal operation. It operates on a stream and didn't return a stream. It could return a collection, it could return an integer, and it could return nothing in this case. So this is called a terminal operation. We have the pipe from the source to the intermediate operation. Finally, we go to the terminal operation. The following example calculates the average age of all male members contained in the collection roster with a pipeline that consists of the aggregate operations filter mapped to int and average. So here we get, this is our source. And after filter, we have a map to int. Change the stream from object stream into int stream. Then we have an aggregate operation. We calculate the average, which after calculate average, we get the result. So the map to int operation returns a new stream of type int stream. Okay, it's no longer an object stream, it's an int stream, which is a stream that contains only integers, integer values. The operation pipes the function specified in the parameter to each element in a particular stream. In this example, the function is person get age. It translates your object person into an integer, which is a method reference that returns the age of the member. Alternatively, you could use the lambda expression. Consequently, the map to int operation in this example returns a stream that contains the age of all male members in the collection roster. So it's a function because it translates one object into another thing. The average operation calculates the average value of the elements contained in the stream of type int stream. It contains an object of type optional double. So this average returns an optional double. Optional double is a new type. Instead of null, it hints the developer this value could be null. So you have to call the specified function in order to get the value. And watch out for null. If the stream contains no elements, then the average operation returns an empty instance of optional double, and invoking the method getAsDouble throws no such element exception. Instead of previously, if you get a variable, okay, there's no way it's null or not null. So the developer is easy to use it as if it is always have a value and get a runtime exception. Here is a different. By declare a variable as optional double, you already told the developer it could throw no such element exception. The JDK contains many terminal operations, such as average, that return one value by combining the contents of a stream. Those operations are called reduction operations. The average is a reduction operation, which we will see more detail in the later sections. Let's go to Eclipse. The example we are talking about is the last one. The roster, again, the source. We get a full set, and we filter through, which is an intermediate operation. Then the stream is passed to map to int. Let's go to check the map to int. Map to int operate on a stream, which is an object stream, and return an int stream. If we check the int stream, int stream is a primitive stream. The element inside it is an integer. And the reason Java 8 introduced a primitive stream besides the object stream, because in order to calculate the elements inside the object stream, you have to do box and unbox. In order to be more efficient, Java 8 introduced a primitive stream like int stream, long stream, and double stream. So by translate your object stream into the primitive stream, it's more efficient. Of course, since you are converting, there need to be a lot of bridging functions. So here is one of those bridging functions, map to integer. Map to integer expect a lambda function which implements a functional interface toInt function. toInt function take your stream's element and return an int. So it translates your object into a primitive type. This is one of the bridging functions, bridging interfaces. There are other bridging interfaces. So toLong function take your element and translate to long, and toDouble function take your element, translate to double. Again, there is a function to translate them back. And translate them in between. For example, translate long to int. And take a long, translate to int. Because you could have a long stream and you want to translate them to the int stream, and you use this bridging functional interface. And there's a, you can write a table about this. You see, int to double, translate your int stream into double stream. And also, let's not just walk through it later. Let's write a table for those translation functions. You have object, you have int, you have long, you have a double, and here again you have int, you have long, you have double, and your table is here. Each row, each column generate a bridging function. So totally you have a lot of bridging functions. 4 by 4, okay. But it's kind of a lot, but you gain efficiency by avoid boxing and unboxing. Oh, we talked too much. We didn't mention about the method reference. The map to int expect a toInt function. toInt function take your element, return an integer. Okay, here is a method reference. It should take it return an integer and take your person and return an integer. So that's what we need. Take a person, return an integer. And finally, the aggregate operation average. average and return an optional double. Optional double is a new type. It's it's intended to avoid it's intended to think differently than a null variable, because a variable, uh, if a variable could be null and the developer didn't use a if variable name equal null to guard the usage of the object, then you could get a runtime exception, a null pointer exception. But by wrapping a nullable variable inside of the optional double, optional, you just mention to the developer this variable could be null. So watch out. This is a programmer's like synthetic way of preventing null pointer exception at runtime. Okay. Let's you get a optional double, and in order to get a value, you call the getAs double. GetAs double just checks the null for you. It's is present, then it's throw exception. Otherwise, it's return you the value. Is present, is false if it has value. Otherwise, it is true. The difference between aggregate operations and iterators. Aggregate operations, like for each, appear to be like iterators. However, they have several fundamental differences. They use internal iteration. What means internal iteration? We didn't specify how we should iterate. We just declare what we want. It's MySQL style. We specify where clause with filter, and we can pipeline them with and we can group them like aggregate operations. So we didn't write a for loop, we didn't write a while loop, we didn't write if clause. We just use a filter, use a map, we use aggregate operations. Finally, we get a result. They process elements from a stream. Aggregate operations process elements from a stream, not directly from a collection. Consequently, they are also called stream operations. In Java 8 Stream API, we deal with stream instead of a collection. So the advantage is you don't have to deal with the whole collection. You just need to deal with one element, the current element in the pipe. Like you have a whole tank of water, and each time you only need to deal with a pocket of water in the pipe instead of deal with a whole tank of water, which is a way when we use a collection. You have to copy the whole collection. You have to get an iterator of the whole collection before you can do anything. But with a stream, you don't have to. It's lazy. You only get the current bit of data, and you can deal with it. And of course, it brings optimization at the computer's level. It can rearrange your pipeline, and it can do optimize, it can do parallel. And this brings a whole bunch of goodies because of laziness. They support behavior as parameters You can specify lambda expressions as parameters for most aggregate operations. This enables you to customize the behavior of a particular aggregate operation. Again, let's compare it with MySQL. Your where clause, you can change it. You can change your where clause, and you get a different result. But the structure is still the same. It's a where clause, but you're sending a different filtering criteria. The map to int, and you can change your code. You can change what inside those MySQL function, and you get different results. You can use different aggregate operations. You can calculate the average. You can do count. You can group by with having, and you can do other things with the aggregate operation. So each time when you change your lambda expression, change your functional reference, change your aggregate operation, you get different result, which make your code flexible, and you don't have to change the structure. So that's a fundamental difference. Previously, you are like C coder, you are the MySQL program developer. Now you are the MySQL programmer, more high level and more declarative and more concise. That's a topic of this section.